Okay, we are continuing with 7/8. This is 7/8 continuing, and that was factoring special cases. And instead of factoring the binomials, the perfect square binomials, we're going to actually factor perfect square trinomial, which means it's 3 terms. Now, one thing I realize is that you may or may not, I can't remember if I showed you this symbol or not, but when it has a plus and a minus like this, that's your positive and negative. So that's like a plus or like addition or subtraction. This one just has to be addition. We'll talk about that here in a second. So you can either have A is A plus B squared or A minus B squared. Okay, so I want to talk to you about, I started filling this out and then I realized I made a mistake. So we're going to look at these and notice they're all trinomials. And then I find the easiest ones to figure out is when the A term is 1. And then you notice that this term 81 and a negative 18, well, what do they have in common? Remember, you have to multiply to get this number, add or subtract this number. Well, hopefully you see that if you multiply 9 times 9, you get 81. And then if you add 9 plus 9, you get 18. But then we got to watch the signs. So we know this one's going to be one of them, and I'm going to explain that here in a second. This one, again, this one. Well, what number multiply to get 144, but add together to get 24? Well, 12. So sometimes it's easy to recognize. But then when it gets to where they're not a 1 in the front, like this one, you could factor out the GCF, which I would do that. But it'll also work. You notice a 4, but it's harder to see here. But when the A term is not 1, it's a little harder to see, but we'll do some work. I'll explain it. So we're going to look at this. And notice it says A squared plus 2ab plus b squared. So factor perfect square trinomials. So first of all, it's a trinomial. Then the first and the last terms are perfect squares. So a squared, so we're going to take the square root. Again, remember how this cancels? The square root cancels out squaring. So a squared, the square root of a squared would just be a. And then b squared, the square root of b squared would just be b. Now, this is where it gets a little confusing because I know we've taught you A term, B term, C term. But we're going to start noticing. Now, you have already, in Delta Math, you've already done something like this. You have done like x plus 2 squared. And we did this in a previous lesson. Remember, you can't just make that x squared plus 4. That is a big no-no. But when you set it out, when you did x plus 2 squared and then FOILed it, you had a middle term, okay? And that middle term was actually double the a times the b. So let's FOIL this out so you can see x squared plus 2x plus 2x plus 4. So it's x squared plus 4x plus 4. So what it is, it's double, it should be the double of the a and the b. Okay, I'll talk about that here in a second. That might be hard to see. Okay, so we're going to multiply the a and the b and then double. Why does that not work? Did I do something wrong? X squared plus 2x plus 2x plus 4. Okay, I'll look at that again. Something's not right. Okay, the middle term is the only one that can be negative in the trinomial. Not that it has to be. So notice you have a plus and a minus here, or a positive and a negative or whatever. The middle term, if anything's going to be negative, it's going to be the middle term. But it doesn't have to be. It doesn't have to be. And the reason is this. In a perfect square it would be, because you're squaring, you're taking the same thing times itself. Okay, so that one, would that one work? We're going to test that one. How do you factor? So first of all, check for GCF. GCF. Okay, always do that. Then take the square root of the first term to find your A, to find your first number. Take the square root of the second term to find your B. Plug terms in the formula. Check the signs in the middle term. Then that tells you to write either a minus or a plus for signs in your answers. So for this example, 4m squared plus 12m plus 9. Well, 4m squared and 9, those are both perfect squares. And that's where I always look at first. I go, oh, if I can't factor out the GCF, if there's no number that goes into all three. I about thought it was 1, but it wasn't. 4 goes into 12, but it doesn't go into 9. And 3 goes into 12 and 9, but not 4, so it has to go into all three. Now, so we're going to the A term is going to be the square root of 4m squared. That's going to be 2m. Then the B term, square root of 9, which is going to be 3. Now, here's this part. You're going to double what you get for A times B. You're going to multiply A and B, then double it. So basically you're saying 2 times AB. So 2 times your A term, 2m, times your 3. This is going to be your middle term. Now 2 times 2 is 4m, times 3 is 12m. That's going to be your middle term. So what's happening here? This should be 2m plus 3 squared. So I look at 4m squared, that should be 2m, 9 should be 3, and then I go ahead and test it just to make sure that it does FOIL out to this. Basically, 2m times 3 is 6, double that, that will give you 12m. Okay. Now, it's not something you have to memorize. We can still do the same thing, all of these. You can still do what we did in 7-7, which I did those notes somewhere else because I did a different method. I don't know where those are. But 7-7 method you could do anywhere. So you don't feel like you have to panic and go, oh my gosh. But sometimes it's easy to recognize when they're perfect squares. So this one, circle the expression that are perfect squares. Well, 81, 9 times 9, or negative 9 times 9, negative 9 times negative 9, and then you have this. So this one's going to be perfect square. Okay, so look to see if you can, if those perfect squares, the first and the last, and then if you take A times B one after, oh, that's what I did wrong. It's fine up here, but my thinking was wrong. The square root of 4 is 2. I double it and get this. So the square root of 144 is 12. Double that, that's 24. So that would work. Square root of 4, because that's a 1 here. Square root of 4 is 2. Double that, I get 4. So that means that has to be a negative 2 to get together to be a 4. Square root of 1 is 1, but when you double it, it's 2. Now I'm just doing this one because all of these are 1s. Here, square root of 36 is 6, but double that, it's not, that should be 12. So that is not a perfect square. Now what about this one? This one I'd almost factor out the 4. I get x squared plus 2x minus 1. So this one, though, I don't think this is going to be a perfect square because you can't square a number and get a negative here. This is not a perfect square. I don't think that's not a perfect square trinomial. This one, square root of 9 is 3. Double that, you get 6, so this one would work. I don't think that one would. It can't, because if you square it, you can't get a negative, and that's a positive. That's what they're talking about. Where's the negative thing? Oh, the middle term. Middle term is the only one that can be negative. So you can't have that as a negative and that as a positive. That doesn't work. Because it has to be the exact same to be perfect square. It has to be the exact same number you're multiplying. This one, square root of 100 is 10. And you get a negative 20. That means that's a negative 10 that you're multiplying by itself and then adding to get negative 20. Okay, square root of 7, or 49 is 7. Double that, you get 14. Square root of 1, double that, you would get 2, so that's not 1. Square root of 8, 64 is 8, but add together it would be negative 16, but that can't be because that's the only one that can be negative. That cannot. Because if you multiply them together, that's going to be a positive. So that's not 1. This one. 64. Yeah, it's the same thing. Okay, so this one would work. X squared plus 16. So square root of 64 is 8. Double that would be 16. Okay, so factor the perfect square trinomials. So look, there's one. Now, well, it's telling us it's perfect square. So we're going to look at it. So we're going to look at this first, look at the second. Now here's what I do is I think, okay, the only way I can get x squared is if I have x and x. The only way I can get 25 perfect square is 5 and 5. Then I look at here. That, if it's positive, that means I can multiply two negatives or I can multiply two positives. Well, with that being a negative, these are both going to be negative. That means that's going to be x minus 5 squared. Now we could go up and do the same thing up here. Okay, so the a would equal the square root of x squared, and that's x. The b would be the square root of 25, which would be 5. Okay, then if you did the 2ab, well, 2 times x times 5 would give you 10x. A negative. There should be a negative somewhere. That's 10. Okay, nope. 10x of that would be that one there. I find it sometimes easier just to see, okay, that's x squared, so that's going to be x and x. That's 25. That's going to be 5 and 5. Well, notice, in order to have a middle term, this sign has to be the same. If you had opposite, it's going to cancel out the middle term. I don't know if that makes sense. Okay, now look. I look at 4x squared and y squared. So 4x squared, the only way you can get that is 2x times 2x. Y squared is going to be y. And then I look at the signs. For that to be positive, I can either have two negatives or two positives. Well, this is positive, so that means that's going to be positive. Final answer is going to be 2x plus y squared. So all we're doing is getting back to that squaring. We're factoring it to get it back to that term. All right, let's look at this one. 25x squared, that's a perfect square. 16 is a perfect square. So then I look to see, can I factor out anything? No. So I'm going to have 5x times 5x. I look at 4. Now then that has to be positive, but that has to be negative. So that means both of these are going to be negative. Now with numbers like this, I might go ahead and distribute out to make sure it does come out to this. Well, that's going to be 25x. I like the FOIL method. Minus 20x plus 16. That does give me 40. Oh, t. Wait, why is that a t? That should be an x. I don't know why that's a t. Oh, maybe, I don't know why, but that should be. So 40x, yeah, 25x squared. So then this is going to be 5x minus 4 squared. Okay, this one, x squared and 16. The only way I can get x squared is x times x. And I go ahead, a lot of times I do this, and then I rewrite it to here. And then I'm going to have 4. That's a negative, that's positive. That means both of them had to be negative. So perfect square trinomials are just looking at your first in your life. If they're perfect squares, most of the time then the middle one that's going to be right. But not all the time. We're going to only see that in chapter 8 when there's not. I should have got some that are not factorable, but that's okay. So we're going to learn in chapter 8 when you can't factor it, what else we can do with it. We turn it to quadratic equation. So hopefully that helped on that page.